Measures of data. Data are a set of values, usually numbers, that represent an event, an outcome, an answer to a question, or the like. Data can be quantitative, like hard data, or qualitative, soft data. This unit will focus attention on quantitative data. Data are collected from a variety of sources and in various ways. The requirements for proper data collection must be clear and unambiguous. Understanding where data come from and how they're collected is of paramount importance. While data are often collected through polling or surveys, data may also be collected from sensors in the environment, such as traffic cameras, satellites, recording devices, etc. Beyond this, data may also be obtained through interviews, downloads from online sources, or other documentation. Data analysis is a set of processes for gathering, inspecting, organizing, and displaying data. Its goal is to discover useful information, to suggest conclusions, and to support decision-making, including forecasting and planning for the future. Data analysis includes various approaches and diverse techniques. Together, the tools of data analysis help scientists, mathematicians, politicians, and business leaders draw meaningful conclusions and to shape plans for the future. Getting reliable data can be a challenge because not all of those polled tell the truth, and not all measuring devices are 100% accurate. There are many other factors such as sample size, gender, age, location, health, and occupation. However, much can be gleaned when data are collected without bias and then organized in meaningful ways to shed light on a topic. It's not unusual for a set of data to cluster near a middle value. For instance, the data for adult shoe size in any population will include data points that are distributed over a range of values with a disproportionate number of data points in the middle of the range. The clustering of these data points can be represented by three different measurements, collectively known as the measures of central tendency of the data: the mean, median, and mode. The mean of a dataset is the sum of numerical data values divided by the number of data items. It is often called the average. The median of a dataset is the middle data value when the data items are written in numerical order, typically from smallest to largest. The mode of a dataset is the data item or range of data items that occurs most often. The mean, median, and mode of a dataset are not always the same, although they could be. Find the mean, median, and mode of the given dataset, 10, 8, 9, 8, 5. To find the mean, we add all the values together, and then we divide by the number of values. So since there's 1, 2, 3, 4, 5 values, we're going to add them all together, the values, and then divide by 5. So that means the average, or the mean, is 8. To find the median, you list the values in numerical order, and then you just pick the middle value. And if there's an even number, sometimes you take the average of the two middle numbers to find the median. But if there's an odd number, then it's just the number right in the middle when you order them from least to greatest. So here, the median is 9. The mode is the value that repeats most often. So since 9 shows up twice, that's the mode. Calculating the mean of values doesn't always result in a whole number. To find the average or the mean of these numbers, you add them together, divide by 8, you get 5.125, and that's fine. Just like I said before, when you have an even number of values, you're going to be averaging the two middle numbers to find the median. So here, the two middle numbers are 4 and 5. Average them, you get 4.5 as the median. The mode, it's possible to have more than one mode or no mode. So here we have 2 4s and 2 5s, so we have 2 modes. Here in this data set, there is no mode since all the numbers are only there once. Find the mean, median, and mode of the ages for the Apollo pilots given in the table. So Apollo mission 11, pilot's age 39, 12, 37, 13, 36, 14, 40, 15, 41, 16, 36, and 17, 37. Alright, so we take the ages and we rearrange them from smallest to largest, or youngest to oldest. To find the mean, we add all the ages together and divide by the number of ages, which is 7. So the mean is 38 years old. All right, the median is going to be the middle number. So since there's an odd number here, the middle number is 37. And the mode, well, 36 shows up twice, so does 37. So we have two modes, 36 and 37 years old. The minimum is the smallest value in a set of data. The maximum is the largest value in a set of data. The minimum and the maximum are called the extreme values. The range is the difference between the maximum value and the minimum value. The range is always a non-negative number. Find the minimum value, maximum value, and range for this set of data. All right, so first we're going to rearrange the numbers into numerical order, from smallest to largest, to help us with the answers. So what's the minimum? It's the number over here on the left. It's the smallest number, 2. The maximum is 17, which is the largest value. The range is 17 minus 2, which is 15. That's the difference between the minimum and maximum value. What is the minimum, maximum, and range for the following data sets? All right, so what I'm going to do is just look for the smallest value. That's my min. The largest value is the max. And to find the range, you take the max and you subtract the min. So for this one, the range would be 22 minus 1, which is 21. Right here, the smallest number is 2. That's the min. The max is 32. So therefore, the range is going to be 32 minus 2, which is 30. All right, here the smallest number is 4, so that's the minimum. The largest value is 18. That's your max. And then the range is going to be 18 minus 4, which is 14. And here you have all of the answers.